to do in 3.3 is learn how to find derivatives of inverse functions. So we're just going to do a brief review of inverses. If you are given f of x and g of x are inverses, if the point a comma b is on the graph of f of x, then the point b comma a is on the graph of g of x. So in example 1, f of x and g of x are inverses. And so I've given you a table for f of x. And I would like you to create a table for g of x. So what would we need to do to create a table for g of x based on what I just reviewed? What will we do? Yeah, Katniss?
What do you that just like kind of like switch out the columns so that like all of the f of x values would now be like the x values and all of the x values would now be the x values.
Yes, that's exactly it. Nice job. So what we're going to do is this will make it negative 26, negative 3. So all you're doing is switching the x and the y values. So again, oh, I needed my tool belt. I have my tool belt. I don't get the tool belt very often. I don't have a tool belt. So here we go. I got my math tool belt. So in my math tool belt here, I use it more in algebra too, but so here's my tool. Okay, here we go. So here's my tool. It is a light switch. So this is to help you remember when you're finding an inverse, you're going to switch the x and the y. Someday, did I tell you about that? Okay, someday I'll tell you about that. This one's a fun one too. But okay, so there's my light switch. I have my tool belt. All right, so real quick, let's write that down. So inverses, I want you to remember you're going to switch x and y. That's our big idea. Now, if you look at f of x, could you come up with the function? Can you tell what's actually happening here to get the outputs? So like if I plug in 0, I get 1. If I plug in 2, I got 9. If I plug in 3, I got 28. It's cubed, right? You see, and then I actually wrote it down already. You're cubing the number and adding 1. So that's f of x. Then g of x is the cube root of x minus 1. So let's off to the side. Let's make a little sketch. And I'm not doing this for perfection at all, but let me graph. So if I have negative 3, negative 26, let's say it's way down here. Negative 2, negative 7, negative 1, 0, 0, 1. Then I have 2, 9, 3, 28. So if you remember a cubic, this is f of x. And again, we're not looking for perfection here. I'm just trying to get a rough sketch of this. And then if I do g of x, which is the inverse, so I have 0, negative 1, 1, 0, then I have 9, 2, then So do you see it's like this? Then do you remember from Algebra 2 that inverses are a reflection over the line y equals x? So if I'm given a table, a set of ordered pairs to find an inverse, I can switch x and y. Graphically, I could take f of x and reflect it over the line y equals x, and in an equation, I can switch x and y and solve for new y. Then we can verify inverses. You remember this? Let me use a little highlighter here. If f and g are inverses, by the definition of an inverse, f of g of x equals g of f of x equals x. Now can you begin to see the connection to our chain rule coming? We were doing compositions of functions, so this is going to be super cool. So watch this. If this is my f of x and my g of x, I can do f of g of x. So that would be f of the cube root of x minus 1. And then f of x says cube the input plus 1. And do you see that's x minus 1 plus 1, which is x. And g of f of x, if I just reverse that order, that would be the cube root of x cubed plus 1 minus 1, which is the cube root of x cubed, which is x. So I just verified algebraically that f and g are inverses. Because what you learned back in Algebra 2 is in order for f and g to be inverses, f of g of x has to equal g of f of x, and they both equal x. All right, so that's a little Algebra 2 review. So now let's go through an exploration. If we want to graph y equals 4x plus 1. All right, let's go graph it. So you know the y-intercept is 1, and we're going to go up 4, right 1, and you can go down 4, left 1. Well, that's a horrible looking line, isn't it? There we go, better. So what is the slope of this line? 4. Okay, now it says graph the inverse. So watch what we're going to do, and you could do this a variety of ways, but I plotted 1, 5, 0, 1, and -1, 3. So if I want to do the inverse, I can just switch my x and y values. Is this coming back to you? Do you remember this from Algebra 2? Okay, good. So this is 5, 1, 1, 0. Wait a minute, did I? Oh, that was -1, 3. I was like, wait. Yeah, sorry, that's -1, 3. Otherwise, that didn't make any sense. So then 1, 2, -3, -1. Okay. Ooh, and what's nice is you can, in fact, see that f and its inverse is a reflection over the line y equals x. So what is the slope of the inverse function? Say it again. Oh, it's 1/4. So that's 1/4. If 2, 9 is on the original line, what point would be corresponding on the inverse? 9, 2. The slope of the line at 2, 9 on the original function is the reciprocal of the slope of the inverse. The difference is that the slope of the inverse is calculated using the point 9, 2 instead of 2, 9. So let's find derivatives of an inverse. And I'm going to show you 3 techniques. Sometimes they work in one manner and not another. So that's why we need some different techniques. And some are easier than others. So let's look at method 1. This method works when it's easy to generate the inverse function while solving for y. On the AP Calc exam, this one's rarely used because it's too easy. But we're going to go ahead and do it just because it could occur. So what you do, step 1, is you are going to find the inverse function by switching x and y. So if f of x in example 2 is x cubed, and we want to find the derivative of the inverse of x at x equals 8. And we can write this one of 2 ways. We can do f inverse in a grouping symbol to the derivative of 8. That's like how you write the derivative of an inverse. So watch what we're going to do. Well, let's first look at the graph of x cubed. So I happen to know that 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8, based on Algebra 2 and pre-calc. So here's my f of x. And watch what I'm going to do. I'm going to find the inverse by switching x and y. And then I'm going to solve for this new y. So this is f inverse of x, and I'm going to be proactive. And I'm going to write f inverse of x equals x to the 1/3 power. So what I want to do is I want to find the derivative of f inverse. So I just bring down the power, decrease the power by 1. Now we're going to evaluate this. This is the cube root of 8 squared. I could put the square inside or outside, doesn't matter. Well, the cube root of 8 is 2, 2 squared is 4, so that's 1/12. All right, now I want to pause here a moment and tie this into the exploration. Could we, in fact, have found the derivative of x, which is 3x squared, and instead of plugging in, then if I want to do the derivative of the inverse, it is the reciprocal at, instead of x is 2, on my inverse, or excuse me, thinking backwards here. So if I have that on my inverse, it's 8, then in f, it's 2. So I could do f prime of 2, which is 3 times 2 squared, which is 12. And so that's just the reciprocal, 1/12. So there's a connection here. So if I want the inverse at 8, that is on the function, the x value is 2, okay? So let's look at another one. If I have g of x equals e to the 3x power, what is the derivative of g inverse at e squared? So let's switch the x and the y. And we're going to solve for new y. And you're going to see just beautiful connections to algebra 2. So I'm going to take the natural log of both sides because I need to get that y to come down from the exponent. Oh, well then it's a good thing we've been talking about our log properties because I can use that power property and bring the power down. What's the natural log of e? 1. Nice job. So that's the natural log of x equals 3y. So y is 1/3 natural log of x. So do you understand that that is the inverse function? So now I want to take the derivative of the inverse. Well, the derivative of the natural log of x is 1/x. And I'm going to go ahead and plug in e squared now. And that is the derivative of the inverse. Now, let's stop and think here a moment. If I looked at g of x, okay, think of g of x equals e to the 3x on g e squared, I would want to know what is the x value. This is really telling me my output. So x would be 2/3. So if I did g prime of x, that would be e to the 3x times 3. And then g prime of 2/3 would be 3e squared. And then notice it's the reciprocal of that, which is kind of cool. So we are noticing, and this one's really, really important. It seems like, it actually is true, if f and g are inverses, then if f of a is equal to b, that means I have an ordered pair a comma b, and if f prime of a is m, then g prime of that output, b, equals the reciprocal, 1/m. Yeah, Bailey?
So I was asking about the log, the natural log. So with this 3y over e, is that being multiplied together? Or would that be like the...
So I'm not taking a derivative. Do you understand that? And this is not a derivative here at all. I switched x and y, and now when I'm trying to solve for y, I take the natural log of both sides because then in my next line I can use the power rule, not the power rule for derivatives. Okay, I'm using the power rule for logarithms to bring the power down. Okay. This is 3y times the natural log e, because that's what the power rule says for logarithms, and the natural log of e is 1.
Oh, okay.
Okay, so that's what happened there. All right, so one method is switch x and y, solve for new y, take the derivative, and evaluate it, okay? Method 2, this is used, and I just love this because it's just tying everything together. So we've already looked at the chain rule with f of g of x, or we're going to see it, and now we're going to talk about implicit differentiation. So method 2 is, if it's difficult to get y alone, we can still switch x and y and use implicit differentiation to get dy dx alone. So watch this. In example 4, it says you're given f of x equals x cubed plus x. If g of x is the inverse of f and g of 2 is 1, what is the value of g prime of 2? So watch this. We're going to switch x and y, but algebraically, it's impossible to get y alone. We cannot do it. But what I can do is I can now use implicit differentiation and I can find the derivative of y. So this is 1 equals dy dx times 3y squared plus 1. 1 over 3 y squared plus 1 is dy dx. Now, this x equals y cubed plus y is the inverse of f of x. So now I have the y coordinate in here. Okay, I have the y coordinate. So that is, in fact, the y coordinate in the g of 2 equals 1, because this is 1 comma 2. I have 1 comma 2 is on f of x. 2 comma 1 is on g of x. So I need to plug that my y value is in fact 1. So g prime of 2 is 1/4. Super cool. Super cool. See, g of 2 means x is 2, but I have the y. Does that make sense? All right, let's do another one. So let me give you a little bit of a head start on this. Switch x and y. Find the derivative of y using implicit differentiation. Then you might get stuck because they didn't tell us the y value for x was 13. And I'll show you how we do that. While I'm trying to be patient and let you get a head start on me, let me tell you about our week. So you have a 3.3 circuit that will be due on Wednesday. Wednesday, I'm going to do 3.4, and there's a really funny worksheet that goes with that. It's about Peppa the Pig. I think that's right. It's Peppa the Pig. It's a riddle. Somebody's been murdered. And then on Thursday, we're going to just press pause and practice 3.3 and 3.4. Friday, I am going to do 3.5, which is nothing new. It's just pausing. We've done a lot. We're going to look at how do you decide which method to use when you're differentiating. Then next Monday, we're going to have a quiz on 3.3 and 3.4. Then Tuesday, we're going to do 3.6. Then we will be having a Unit 3 test. Well, there's only 6 sections, I believe. I need to double check, but I think there's only 6. So we're only going to have a 1-day test. We're not going to do a 2-day because this content was so short. I haven't decided yet. It could possibly be both, but I'm leaning towards all no calculator. I am leaning towards all no calculator. But I'll let you know once I get a little further along. All right, I am switching x and y. I'm going to use y prime this time, for those of you that prefer that. All right, can you give me thumbs up? Did you get y prime? Did we get y prime okay? All right, so that's an important piece. Now, if I want to do g prime of 13, this is the x value. Okay, this is the x value. And I need the y value. So I'm actually trying to solve this equation. So let's go ahead, and you would need a graphing calculator, so that's why I'm not 100% sure which route I'm going to take. So what you're going to do is you would use your graphing calculator, type this in, and go find the x-intercept, or the 0. So can you grab your graphing calculators, type that in, 3y to the 5th, plus 6y to the 4th minus 9. You're going to graph it. You'll press your menu, analyze, and do the 0. On your iPad, you could grab Desmos and pop it in there. Anybody get it? Thought I heard it. It's 1, right? Good job, good job. Oh, sure, yeah, this one would be. Good job, Jim. Yeah, you really could. Can you see that just glancing at it, if you had to like guess something, you see 3 plus 6? Yeah, great, that's awesome. So this is gonna go G prime of 13 is 1 over, and I'm really gonna plug in 1, which is 1 over 39. It's possible that method 2 can be streamlined a bit by using the following formula. So before I give you the formula, I want to show you where it comes from. And this is, so we've reviewed implicit differentiation, so there was a purpose and a point to that. And we're also going to use it in the next couple of units. But now we're going to look at the chain rule. This is super exciting. Remember, if f and g are inverses, that means f of g of x equals g of f of x equals x. So watch what we're going to do. If we just take one piece of that, f of g of x equals x, and I find the derivative of both sides. Now, f and g are inverses, okay? So watch, this is the chain rule. So it's f prime of g of x times g prime of x equals 1. Now stop and think here. G prime of x is the derivative of f inverse, right? G is the, and I have to tell you, this is one section for me that gives me great pause, that I have to really stop and concentrate. Okay, I'm the math teacher. And this section, I have to really stop and concentrate because it, to me, they're saying f and g, and I'm like, okay, but g is f inverse, and the x of f is the y of g, and so to me, it gives me great pause. So I just want you to remember that, watch this. So if g prime of x really is the derivative of f inverse, I could divide both sides and get g prime of x equals 1 over f prime of g of x. So this is a situation where I don't memorize this formula that's in the box. For some of you, you prefer to do that. When this comes up, and you'll probably see 1 or 2 multiple choice questions on the AP exam. It's rarely on a free response. So that's good news. It's on a multiple choice. But because we have so much to memorize and I don't like to put it in my brain, I just go, okay, what do I know about inverses? I write down, it takes me like 30 seconds, f of g of x is x, do my chain rule, and I figure it out, okay? So you can always come back to that. Let's just figure it out. So watch this then. Here, instead of using the letter g for the inverse, you can use f inverse. So that is the same thing. So now what they're going to do is very likely in the next part, okay? This is where they're going to get you, so you have to do it this way. You can't use method 1 or method 2. They're going to force you into this method 3. So let's look at example 6. Let f be a differentiable function such that f of 5 is 20, f of 7 is 5, f prime of 5 is negative 4, f prime of 7 is negative 5 halves. The function g is differentiable, and g is the inverse of x. What is the value of g prime of 5? So watch what we're going to do. g prime of x is 1 over f prime of g of x. This is what we just determined above. So if I want g prime of 5, that's 1 over f prime of g of 5. Nowhere in the given did they tell us g of 5. However, we have a tool in our math tool belt on inverses. Can anybody tell me what's g of 5? Carter?
7.
Awesome. How'd you get it? You got it.
So f of 7 is 5, so the inverse of that would be g of 5.
You got it. Okay, this is on g. So this is where it gets tricky. Okay, this is where I have to pause and think. So if f of x is 7 comma 5, then g of x is 5 comma 7. Now, oh, there's a reason why they gave us f prime of 7. But they also gave us f prime of 5 in case we're confused, okay? So this is going to be 1 over negative 5 halves. Dividing by the reciprocal would give me negative 2/5. All right, let's look at example 7. Example 7 says the function h is given by h of x equals x to the 5th plus 3x minus 2. H of 1 equals 2. If h inverse is the inverse of h, what is the value of the derivative of the inverse at 2? So if I want to use this technique, and you could do it with method 1 or method 2, but this would be h prime of h inverse of x. So this would be h, the inverse, right? That was h inverse of x. This would be 1 over h prime of h inverse of 2. So remember, if h is 1 comma 2, then h inverse has 2 comma 1, right? Let me say that again. The reason why they gave us h of 1 equals 2 is that the inverse would have the point 2 comma 1. So then, what's h inverse of 2? What's h inverse of 2? 1. Now I need h prime of 1. Well, here's h of x. Whoops, we got to go do h prime. That would be 5x to the 4th plus 3. H prime of 1 would be 8. Does that make sense? That makes sense. So to me, you just have to be really careful with inverses. You're switching your x's and your y's. All right, now tables. Most likely you're going to see a table as a multiple choice, or like example 6. Example 6 or example 8 or 9. That's typically how the multiple choice goes. So the table below gives selected values for a differentiable and decreasing function f and its derivative. If f inverse is the inverse function of f, what is the value of the derivative of f inverse at 2? I'm going to pause a moment, and you're going to have to use our formula in the box. Let's go ahead and see if you can do it. Write out the formula, plug in, and really think about this. All right, if you did it correctly, you would have gotten negative 1/8. Did we get it? Oh yeah, good, good, good. Okay, let me work it out for those of you that might still be struggling just a little bit on it. Whoops. So I'm going to do the derivative of f inverse of x is 1 over f prime of f inverse of x. So then I want the derivative of f inverse at 2. Okay, so I don't have a column for f inverse, but do you understand that f inverse of 2 means on the original function, what was y? Y is 2, and I'm trying to find that x value, so that would be 1. So that's 1 over negative 8, which is negative 1/8. All right, then if you haven't already, go ahead and move forward on example 9. Try those two using a new set of tables. And I strongly recommend that you write this step out just because it's going to help you remember it, not because you have to. All right, in letter A, what is G inverse of 1? Negative 1. Nice job. So then I go to G prime of negative 1, and you get negative 1/5. Dividing by a fraction is the same as multiplying by the reciprocal. All right, letter B, I got negative 1/2, negative 1/2 as my final answer. Let's see how. So I get G inverse of negative 3. Okay, what is G inverse of negative 3? 4, right? You get 4. So then I go to G prime of 4, which is negative 2. You could leave it like that, or negative 1/2. Yeah, okay. Yes, this one works all the time. So if you just want to remember 1, this is the one.